So in this demo, we're going to learn, or I'm going to review for you the different parts of methods. And those different parts are. Shh. So I can open up my demo. We're going to put the blank Java in source. We're going to start this demo. We're going to copy files to source. When I copy file to the source, one of the source files is now called blank demo. It's up here, blank.java. I'm going to open that up to start. I'm going to close my other things. Currently blank is empty. And the first thing I want to do is to comment what we're going to do with blank demo. We're going to make this a methods demo. And the methods demo, this is to review the parts of methods in Java. And the parts we want to review are the method signature. We want to review parameters. And there are two kinds of parameters to review. We want to review class parameters. And we want to review basic or simple parameters. We want to review return types. We want to review a method overloading. And the last thing we want to review is recursion or recursive methods. All right, so we start with comments. Now, here I have a name already, methods demo. We're going to use this for the name of the file and the name of the class that's in the file. So I'm going to change the name of the file. I'm going to right-click on the file and choose refactor and rename. I'm going to rename the file methods demo. And when I do this, it changes the name of the file. If I had a class in the file, it would change the name of the class as well. And any references I have to the old file name can also be changed. So here we have a class. So this time I'd like you to follow along. We're going to type public class methods demo, open curly brace. So the first thing we want to do is we want to review a method signature. Whoopsie. The method signature is also the public interface to the method. It's another word. And the method signature consists of 1, 2, 3, 4 parts. We start with the access specifiers. The second part is the return type. The third part is the method name. And the fourth part that's in parentheses are the parameter list. These four things together, the last two parts create the method signature. The method signature uniquely identifies a method. Uniquely method. And we're going to get back to the method signature when we get to method overloading. So let's make a new method. You've made this method before. Access specifiers, public, static. Return type, void. Method name, main. Is it familiar? Parameter list, capital S string array is the return or the parameter type, and the parameter name here args. Methods have a method title, or method signature, and a method body. In main, we're going to call all our other methods. So the first thing we want to do is play with parameters next. So we're going to make two methods that play with parameters. And we want to call them and see what happens. So let's make two kinds of parameters. We need a class parameter and we need a simple parameter. So my simple parameters, I can have ints. Int I0 equals 1 and I1 equals 2. So those are simple. And a class parameter is going to be int array. And in this int array, we're going to put two values, 1 and 2. So these two sets of parameters, whoops, I need to name this int array. Let's call it I. These two parameters have two different kinds. One is simple and one is a class. When you pass them, when passed to a method, the parameters themselves are copied into the method's parameter list. What does that mean? So let's make two methods to do this stuff. We want to print them. So we're going to system.out.println I0 colon plus I0 plus I1 colon plus I1, whoopsie, plus I colon plus, and what's this called? Array dot print. I'm trying to do a print array something. Let's see if we have one here. Nope, that's not it. I forget the name of it. Array list or lists? Arrays? Lists? Nope, I don't know what it is. So I'm going to make my own printer. So Java has a method that will allow you to print a whole array. And I don't remember what it's called. So we're going to make our own printing method. So let's make a new method to print the array. And the method is just print array. And it takes an integer array, I. And then we'll do a print line at the end. So let's look at this print statement. And let's do a before in here. We look at the print statement. We have four parts to it. We're going to print the word before. We're going to print our variables before we call them in something. We're going to print our array using a function or a method we're going to create called print array, and then we're going to print a new line. So this will print out all the variables before. Then we're going to run the two functions. We could call, what's this, parameter method, param method 1. And param method 1 will take I0 and I1. And param method 2 will take I. Then we want to print the afters. So I'm going to take my print statements, copy them, paste them after I run the two parameter methods. And I'm going to take my print before, whoopsie, copy it, and paste it. So Quadro, can you keep it down? I can hear you over here. Shh. And the people who are talking to Quadro, also please keep it down. Shh. Okay, then this is after. So here's a test of parameter methods. We print what we have going into the parameter methods. We call the two parameter methods. We print coming out of the parameter methods. So we need to make our three methods that we're using. We have print array, which does not exist yet, parameter method 1, and parameter method 2. So let's do print array first. In the print array method, we need to do the same kind of signature. Remember, signatures are up here. So inside our class, we're going to print another signature. We need the method Access specifiers. The access specifier for this method is public, static, void, and the name of it is print array. So I'm going to copy print array, Control copy, paste it here. The parameter of the print array is the same type that I is. I is an int array I, so I'm just going to copy the type and the name and paste it into the parameter list. Now all this is supposed to print array I, so I'm going to do a for loop for int a equals 0, a is less than I dot length, a plus plus. We're iterating through the array, and all we need to do is print each element in the array. And so to print the element, I'm going to say, do I do a comment, or I just do the element itself? System.out.print, and I'm going to print the element itself, which is I of A, and then a space. And that will print the array. The next two parameters I need to create before I can run the program is parameter method 1 and parameter method 2. And these will be testing parameters. We'll test if a method changes the values in the calling function. So we want to know if we pass a parameter to a function, can we change it in the calling function? So main is going to call parameter method 1 and parameter method 2. And we want to know, does parameter method 1 and parameter method 2 change the values inside of main? We know the values can change inside the parameter method. So let's do parameter method 1 first. It is a public, static, void. It's called param method, or meth1. And it takes two ints, a and int b, as parameters. We want to change the parameters and print the match word, so we're going to say b gets what's in a, and then a gets, I don't know, 43. And we print them out here. System.out.print param-meth1 I0 colon space plus A plus space I1 colon space plus B. So parameter method 1 is done. All it does is changes B to what A is and changes A to 43. Let's make that 42. And then prints them. So let's look at parameter method, parameter method 1. Let's look at parameter method 2. It's the other parameter. Signature, public, static, return type void, method name, param. Is it param method or para method? What do I have here? Param method. Param meth2 takes an integer array, and we'll call this integer array A. So we assume integer array A has two values. So we say A of 1 gets A of 0. And then A of 0 gets 42. And then system .out.print A of 0 plus space plus A of 1, and let's announce who's printing these. This is in param method 1. Param method, 2. So let's look at our print statements. I'm going to hide my print array because we don't need to see that. In main, I print what we have in the variables. I then send those variables to two methods, and then I print what comes out of those two methods. The methods themselves change the variables and then print them. So when we run this, what do we expect to see? Let's run it and see what happens. Oh, let's run this one and see what happens. Why is it running something else? Hello. There it is. Oh, I need a print line there. System.out.println, nothing. This will make it look prettier. Last time we ran it, parameter methods printed right next to each other. I want a space in there. So I want a space in front of param method 2. All right, so let's look at the output. In the output, we see our before. I0 has the value 1 in it. I1 has the value 2 in it. I need a space there. So let's put a space after I1. Rerun it. And we need a space after I1 here as well. And rerun it. Okay, I'm just making it pretty. There it is. So we see the first one. I0 is a 1, I1 is a 2, and then I is 1 and 2. We should print I. There's I. Here. That's print array. The print array, I'm going to change that. We need to add something. I need an I in front of this. System.out.print space I colon space. Now it should be even better labeled. Much better. So before, I0 is a 1, I1 is a 2, and I is the numbers 1 and 2. In parameter method 1, we change I0 and I1 to 42 and 1. In parameter method 2, we change I0 to 42 and I1 to 1. Notice they are the same, right? 42 and then 1, 42 and then 1. And when it comes out of the methods, the simples do not change. They remain what they were going in, but the class parameter has changed. See that? Class parameter changes. Simple parameters do not change in main. This occurs because when you pass a parameter to a function, the parameter itself is copied. A class parameter is not the value. A class parameter is the location in memory where the values are, and that location is copied. So A, in my parameter method 2, is a copy of where the values in I are stored. It's the same memory, and so when I change those memory locations, I change the same memory for I in main. So this I in main is in the same memory as this A down here in parameter method 2. So you can think of this as an alias. For the simples, we create new memory for simple parameters. And into those we write the values that were passed. So in main, I0 and I1 have the values 1 and 2. Those values are copied and stored in parameter method 1's A and B. When I change those, I just change the copies. I do not change the originals. And then I print them. And that's what happens with class versus simple parameters. So we've done method signature. We've done class versus simple parameters. Let's look at returns and return types. So in main, let's just return two values. System.out.println return int. Let's say int 0. Return int 0. System dot out dot println return double 0. And the last one, we're going to try to do this one. System.out.println return void. So I need 3 new functions to make: return int 0, return double 0, and return void. Let's copy these things here. No, let's just write them. I'm going to write them right up here so we can see them. I need a function called return int 0. Access specifiers: public, static, return type, an int, name, return int 0, parameter list, empty parameters. All we do here is return a 0. Good enough? Next one, public, static, int, double, return double 0. You can probably guess what this one does. Return 0. And then the last one, this one's going to fail on us. Public, static, return type is void. We want to return a void in this one. Return void. And we can try return 0. Now we see the first error show up. Here, when I'm trying to return a 0 for my return void, the 0 value is an int or a double. It's a numerical value. Void is nothing. I cannot return a value with void. No values returned to a void function or method. So return 0 does not work. We do not need a return here. Notice, do not need a return for a void function. Or sorry, method. So there's no red lines if there's no return here. Remember I had return 0 and I got a red line. It doesn't like return 0 because it's a number. I don't need to return at all. Look, no reds. I don't need to return at all. But voids can return nothing. Void methods may return nothing. So void and nothing are synonyms. All right, also notice what happened in the print line now. Now that we have our methods ready, the printing return int 0 works, printing return double 0 works, but printing a void does not work. Print line does not know how to print a void. Does not know how to print a void. It does know how. Print line can print doubles. Print line can print ints. Cannot print a void, so we need to comment out to print void. But we still can call the function. Return void. Now we see that our main has no errors. It has warnings for print line. And when we get to overloading, we're going to play with print line. So let's run this function and see what we get. So let's change our prints a little bit. So this is return 0. So we're going to say ret int colon space plus. And for return double, we're going to do ret double space plus. Now I got an extra double quote here. Get rid of that. And with this, we should show the different values that run. So let's run it again. Looking at the bottom output, return int returns a 0. Return dub returns a 0.0. Why does return int return a 0? Return dub return a 0.0. It's formatted differently. Why?
Because a double is decimal, you can do decimal spots and can only do single digits.
Exactly. So what happens, thank you, Nevada, what happens is this integer gets returned, And before it gets to main, we see that return double returns a double. So this integer is cast into a double, and that comes out here where return double is called. And so instead of the name return double here, it gets the double value 0. And that's a 0.0 if you were to write it. Then that goes to print line. So print line sees a 0.0 here, converts it to a string, because this plus takes 2 strings, and we convert the double to a string double, and we see when we do that conversion the 0.0. Do notice that if we made this one here a 0.0 to return to an int, we would get an error, and this error says you're losing precision. You cannot convert from a double to an int, but you can convert from an int to a double. To force a 0.0 to change to an int, we have to explicitly cast it. Now it's happy. So let's change this back to a full integer. All right, so that is return types. The next thing I like to do is method overloading. So let's play with system.println and see what happens. So method overloading, we're going to play with system.out, .println. And so what I'd like you to do is type system.out and see what shows up in the IntelliSense or the suggestions. So let's do that. System.out period. Let's look at print lines. PRINTLN. And we see a whole bunch of print lines. Do you see them? First one says string, one has blank in it, one has object X, one has Boolean X, one has character X, one has character X, one has double X, one has void, or float X, int X, ln X. All these are the parameters that go into print line. If we look at Boolean X, we see the signature for print line here. Again, the signature has access control, return type, function name, parameter list. How can we have a whole bunch of print lines that all have the same name? How do we uniquely identify a program or a method? You uniquely identify a method from the signature, which is the method name and the parameter list. So this println string X is different from the println object X, which is different from the println double X. They're all different functions. They all have the same name, and they all do roughly the same thing. They print something, but they have to format that thing into a string in order to print it. So we see println can print a string, Println can print, let's copy this thing to make it easy on me. Println can print a double. 0.0 is a double. Println can print an integer. 0. 0 is an integer, and so on. When we run these, we see the different formats that println does. A string, 0.0 is a double, a 0. The operating system or the compiler knows which println to call from the parameter. It sees what the parameter is and then calls the appropriate println. So this is method overloading. You can make your own overloaded methods. So let's make 2. System.out.println. And the method we're going to use is called add. And here we're going to add a string, string1, and a double, 0.0. Println doesn't know how to print add because add doesn't exist yet. System.out.println. How much time do I have? Oh, plenty of time. Perfect. 2 minutes. I put an I in here. It doesn't matter. Oopsie. Wrong one. Right here. Go AI. N. Here we go. The second add is going to go 0.0, comma space, string1. Can someone predict if this is the same add? Is add string1, comma 0.0 the same as Add 0.0 comma string 1. No. The order of the parameters matters. So when overloading, make a different method signature for each method of the same name. So for overloading, names are the same. Parameter list is not. And order of parameters matters. So let's make these guys. We have add, public, static, void, add, and the first one takes a string, we'll call it P1, and a double, P2, and all we're going to do in add is just, return something. Let's return a string. And we're going to return first add. This needs to be a P2. There we go. And for the second one, public, static, string, add, and the order is now double, comma space string. Notice, do I have to, let's see if does, oh no, it doesn't let me do it. So Java is not letting me get away with just listing the types. C++ would, but Java does not. I do have to name my parameters, P1 and P2. And here we're going to return second add. And we run this. So here's parameter overloading. I have a name of a function called add. It's the same name. I call it twice. The first add has a string and a double as parameters. The second add has a double and a string as parameters. When I run it, notice that they are different methods. String first, then double is first add. String first, then double. Second add, double first, then string. Names are the same. Access control is the same. Return type is the same. The only thing that is different is the parameter list. Same kind of parameters, different order. Therefore, the signature is different, and therefore these two add functions do different things. The same thing is happening when you use println. Println can print strings or doubles or integers, but it prints, right? The overall concept is the same. Println prints things, and the things you print are different. So you throw different things at println, and it handles all the different things, because there's a different method for each thing you're trying to print. Okay, last thing we're going to do is recursion. Recursion. A recursive function or method is a method that calls itself at least once. So all recursive methods must have a logical path in the algorithm that does not call itself and a different logical path that does call itself. All right, so let's write a print string backwards method. So we have system.out.println print string backwards. And print string backwards will take a string. And let's print me backwards. Someone has to use the bathroom? All right, go ahead. So you probably know this already, yes? Good. How much time do I have? 35 minutes. So I have about 7 minutes. Let's do this in 7 minutes. So print string backward does not exist. We're going to create it recursively. It is a public static. It returns a string, and the method is called print string backwards. I spelled it right. And it takes a string to print. And all we want to do is print the string backwards. And to do that, we're going to create an output. And so we're going to return, I'm sorry, it says if string to print dot length is greater than 1, then we're going to return string to print dot character at string to print dot length -1 plus print string backwards of string to print dot substring 0 string to print dot length -1. See if this is right. Do I got all my parentheses in the right place? Print string backwards, print string back. Did I spell it right? What's wrong here? Method is undefined for the type MethodsDemo. Print string, did I spell it wrong, didn't I? Oh, I have a parenthesis in the wrong place. That's what the problem is. Right here. Parenthesis in the wrong place. And I have another parenthesis in the wrong place. I know it works. Okay, so let's look at the, we have some, we have a red thing here. Something's wrong over here. Too many parentheses, maybe? Delete the token. Too many parentheses. All right, so I think I have my parentheses correctly. Let's walk through and look at this. Oh, I'm sorry, I need an else. Else, now this length is 1. We're going to return string to print dot character at 0. I've done that right. It's mad. Cannot convert from character to string. Yes, we can. Watch this. New string what? String character is undefined. Ah. Can I cast it? Maybe we can cast it. We can't cast it. There's no caster available, so I cannot convert this damn thing to a string. We can't return the character, so I'm stuck. I need to convert from a character to a string, and I do not know how to do that. Character array. No. I'm stuck. I'm trying to do fancy fancy and it's not working for me. Damn it, damn it, damn it. So I have to return something here. I have to return the last string. Maybe we can return the substring. Let's do that. Or just return the string itself. It's length 1. Duh. Here we go. String to print. Voila! Okay, that works. Okay, so let's walk through this. I got it. Sorry about that. All right, so let's walk through. Let me do it in here so everyone can see it. Let's walk through this last. This is a recursive function. It will call itself right here. Print string backwards. So print string backwards will call itself if the length of the string it wants to print is greater than 1. Otherwise, it prints that string. And when we call the second time print string backwards, it's calling the substring of the original string and excluding that last character. So we stop the substring at the last character. We don't print the last character. So we add those two characters together, and concatenation should add the character to the string. So I could have done it that way too. And this will come out print string backwards. So let's run this and see what happens. Print string backwards. You see it right here. And this did that recursively. So let's walk through the recursion and see what happens. I need to put a breakpoint here and see if we can run to the breakpoint. So now I'm going to, I want to do a conditional breakpoint. Let's see if we can change my breakpoint. Breakpoint properties, here we go. So I'm toggling the breakpoint. We're going to do a hit count here, and we're going to count, how many letters do I have? Lots of letters. We're going to count 6 times. Apply and close. So the sixth time I hit this breakpoint, we're going to stop. Let's run the debugger. To run the debugger, right-click on the name of the file, and you're going to do, where's debug as? Debug as Java at. When you run that, eventually it should hit that breakpoint. Crap. And we switch, and we should be able to see the call stack in the switch. Here it comes. Where's the call stack? Variables, breakpoint to sessions, debug shell, problems. Where's the call stack? We have to see the call stack. I'm out of time, gentlemen, but we do have brunch. So let me use up some of your brunch if that's okay with you. If it's not okay, let me know. So, okay, good. So I need to see the call stack. Console debug shell outline. Is it the outline? No. Expressions, breakpoints, variables. Where's my call stack? All right, I can't find it. I don't know where the call stack is. Console, no. Problems, no. Debug shell, no. I'm trying to find a call stack. I can't find it, so I'm going to release you. I'm going to look for the call stack. All right, so sorry about that. Let me just tell you what you're going to see once we find this. Oh, well, here it is. Here it is. I found it. Yes, perfect. Okay, here's the call stack right here. So if we trace the call stack, well, let me go over here. We see it. The last function called is print string backwards. It's stopped at line 72. This function has been called by print string backwards at line 73. That's right here. This function has been called from this function. It's been called from this function, been called from this function, called from this function, and here's main. So main calls print string backwards right here, and that's this first call right here. Called in main. Main is stopped at line 68. 68, calling print string backwards. So this is the call stack. If we have no way to stop this call, or if we get rid of this if statement, I don't know how to comment it out. Is it control slash? No, that's the whole name. I need to comment this. How do I comment to you? I just delete you. Here we go. If instead, and there's no else, and we run this to the breakpoint. Actually, let's remove the breakpoint. Let's just run it. We get a crash. What's this going to crash on us? Oh, it crashed. Why did it crash? We have a string index out of bounds. So it crashed. It crashed drawn. It should have emptied the demo. Oh no, it did index out of bounds, that's right. So it keeps calling itself and runs an index out of bounds. But you can get a Stack Overflow error if you don't do this right. Okay, so that's it for the demo. I'll do the summary some other time. Sorry about that.